Hello, good morning students. In this video, we will solve one line balancing problem by using Flexsim 2020 version. For that, it is expected you should know to create a virtual plant on Flexsim. That is to know the capacity of considered plant, and after that we can solve line balancing problem. So we can start with new model. Click, then select model unit, that is unit according to SI, time in second, then length in meter, fluid liter, and respect to time. Okay, then we will create one uh, virtual plant. Suppose we consider there are four operations. So just start with source, that is input, and we required one output source. Then there are four operations, so we required four machine: processor 1, processor 2, processor 3, processor 3, processor 4, and we will use q before each machine: q1 for processor 1, q2 for processor 2, q3 for processor 3, then q4 for processors 4. After that, we will next step, that is connectivity of these all operations. Connect object via A. So select first, means product flow from source 1 to Q1, Q1 to processor 1, then Q2, next processor 2, Q3, processor 3, Q4, processor 4, and lastly output, that is sync. Okay. Next step, to define arrival time of product, or uh, define machine name and its property, just like setup time and running time. So first define source, type of source, that is type box type, and arrival time. Suppose we consider 10 second. After each 10 second, product will arrive from source. Apply. Okay. Then define queue size, that is waiting. So we consider maximum 1000 as usual, or default setting. Okay. Repeat for next q2, again 1000. Okay. q3 same 1000. Okay. q4 same setting. Okay. Then processor 1, suppose this is lathe machine. Lathe machine having setup time 5 second and process time 5 second. Apply. Okay. Then second machine, double click on that and define their property. Suppose this machine called as a drilling machine. Here setup time 6 and process time maybe 9 second. Apply. Okay. Third machine, suppose this is milling machine. Milling machine, setup time 5 second and process time 15 seconds. Okay. Last machine, double click on processor 4. Last machine called as a suppose cutting machine, or there is a cutting operation on that machine. Setup time 2 seconds and process time 12 seconds. Apply. Okay. Here our virtual plant is ready for operation. Means we create one virtual plant having 4 processes by using 4 machines. First, lathe, drill, milling and cutting. Then next step, that is define runtime. So here we define runtime. 8-hour shift means in terms of second, that is 2880. Then reset all and run. We can adjust run speed from here. We can increase speed according to our convenience. Then after 2880 second, it will stop. Here our main objective to eliminate bottleneck in line. Bottleneck also called as line balancing. So in sync we'll get 141 product within our given range or for time slot out of 287. Means there is some problem in machine, or there is a no balance, because we lastly we required output is equivalent with input. That is nothing but line balancing problem. So there are 2-3 way, so we can minimize or eliminate bottlenecking in line. So first way to manage arrival time of source, this is uh, or we can say that this is depend upon first machine setup time on operation time. So if you check setup time and operation time of first machine, that is setup time 5 and process time 5, means total 10. So sorry. So at least 10 seconds is required from source arrival. So we check here, we already given arrival time 10 and there is no problem or bottleneck create before lathe machine. So up to lathe machine it is okay. Then after that uh, there is a bottleneck on Q2, means before drilling machine. So if you adjust or we apply some method, means which already studied in method study, we can apply different methods technique to minimize setup time or cycle time. Suppose we apply some certain methods and techniques to minimize setup time. For that we use some fixtures or some another arrangement, and suppose we decrease setup time up to 4 seconds and process time up to 6 seconds. Then apply and OK. Then again check by using run, reset, run. Okay. Then sync means output again 141 and input 287, means still line not balance yet. So check Q1 clear, Q2 clear. After that position of Q3, yes, there is a lot of pending work due to milling machine. So double click on milling machine and check setup time, process time. Suppose we decrease setup time by certain technique or methods 4 and process time 12. Apply. OK. Then again repeat this procedure, reset and run. Output, check output. Yes, output increases due to decreasing cycle time of milling machine. Increase from 141 to 177, but not we get 287. So um, what will happen? We can decrease setup time as well as process time according to our limitations, but still line not balance. So another way to minimize this bottleneck, after that we can increase again one machine, milling machine, to process that operation. So I'm here use another milling machine, milling machine, second milling machine, or reset, use processor. Just a minute. Select process. Select and drag. So double click on processor 1 and label it milling machine 2. First is that is milling machine 1 and second milling machine 2 with setup time same as machine 1, that is 4 and 12. Okay, so the same property given for machine 2 also, 4 and 12. Okay, then connect it from Q3 to milling machine 2 and again send to Q4. Okay, means in this way we complete our. Okay. Then again reset, run for same time period, check. Yeah, wow, output increase up to 202, still pending some work. Then check where is the bottleneck. So here we'll get bottleneck before cutting machine. So check property of cutting machine. Then suppose setup time not decrease, and we can modify process time, suppose 9 seconds, and apply, reset, run. Then check output. Yes, increase 257. Then still will not get 100% line balancing. So after checking arrival time, then process time of cutting machine, so I think again we need one cutting machine. We insert one cutting machine, then label it, that is cutting machine 2. Property same as first machine 2 and 9. Apply. Okay. Then again reset and run the model. 257 and 287. Sorry, we forget to connect machine 2 with respect to Q4 and up to sync. Sorry, again reset and run the model. So nearer to 100%, that is output 283 and input 287. So in this way we can minimize or eliminate bottleneck by applying various technique, uh, such as adjust arrival time of product from source, then check whether queue having a certain pending object or not, then apply a certain method study on operations and check whether we can minimize setup time or process time. If you not further decrease setup time or process time or indirectly cycle time, so increase one another machine to perform that operation and check, uh, so we will get 100% output or not. Okay, thank you.